Hello, welcome to Networking Field Day 14. You are about to watch a presentation from Kentik that includes a group of invited social media influencer delegates who are here to ask questions, make comments, and offer their opinions about the technology of Kentik. If you'd like to learn more about this and other videos in the series, please go to our website at techfieldday.com or check out our YouTube channel at youtube.com/techfieldday.
So what we're going to do is talking about the streaming, we'll call it anomaly detection. We're going to roll into actually showing a little demo about how the anomaly detection is actually configured and then how it's actually in use. So since we don't expect users to be able to start from scratch right out of the gate and build what could be a fairly advanced policy on how to detect something, we have a template, we'll call it a library of templates that people can start with. And to give an idea of some of the things that we can look at, so give you a scope of the capabilities, is, there's easy things that people will think is common sense, but a lot of platforms don't do it. Like, tell me if a particular interface in my network is over some threshold or over what it normally is doing for this time of the day, right? And that rolls into some attack things. I want to know if there are certain ports on the internet which are known bad ports. A lot of this stuff you don't even need to look at a baseline for. Why should I be getting UDP port 1900 at 10 megabits per second, or even port 123 at 100 megabits per second, right? So we have some kind of very basic, just look at the bad ports and see if we're receiving a reasonable amount of traffic on them. And then we have things like very high packets per second, right? And this one is where things begin to get complicated, because you've got your network which has a web server that normally doesn't do much traffic, and you have a DNS server that's normally doing 100,000 packets per second, and a cache server from Akamai that's normally doing 200,000 packets per second. Right? So you can't just set a static threshold in your network, and you don't want to break your network into little teeny pieces and have to define each one of them. So here's, and we'll bring up the actual configuration of this, but this is an example of where you'd want to use baselining. Say, let's look at the top 500 IPs in my network and build a baseline for every one of those. And then you may say, well, what happens if IP number 2000 isn't in that, and I'm not building a baseline for it? You can make the assumption that if it wasn't in that list, you can use the lowest guy that is in the list. He was under that, right? And usually when somebody begins to do something bad, even in a network with millions of IPs, that IP moves up into the top 20 very, very quickly, right? So looking at a fairly small number of the top X will give you a fairly representative, very good representative indicator. But then things get a little bit more complicated. Like, tell me if a particular site in my network is sending to a particular country or region, and that shifts. Okay, so my Amsterdam site is normally sending a whole bunch of traffic to London, and now all of a sudden my Amsterdam site begins to send a whole bunch of traffic to the United States, and I want to be notified about this. So this is beyond DDoS. Now we're actually talking about peering. We're talking about people that are purchasing transit, people that are looking at performance, like gaming companies. They can use it to detect when things shift around that will affect their service. So let's actually drill into one of these and take a look at it.
So just a quick question while you're doing that, because I think I read that you guys are using RTBH. You've got a dynamic RTBH that you can hit with the monitoring. Is that accurate?
Yeah, so you can RTBH. We have integrations with A10 and Radware. We have a call out to URL coming that's in the SQL system, but coming into this, so you can do whatever integration you want. Right now, people that do FlowSpec actually sort of RTBH it in the whole route map and generate. Okay. And as we talk to customers, we just find out. Right now, we've seen a lot of uniqueness in FlowSpec, but we're open to building more FlowSpec-y stuff too.
Yeah, because a lot of enterprises deal with volumetric attack, and they struggle with how to deal with volumetric attack. And yet, in the service provider world, it's pretty fair. It's an RTBH, and you go on about your day. And a bunch of other mitigation techniques. I haven't seen it as much in the enterprise, but something like that. Yeah. Being able to RTBH, inside of an enterprise would be helpful if you had that ability to kind of wrap this dynamic detection around it. That's cool.
We have had some people experiment, even without FlowSpec, on using RTBH to take a particular policy here and say this is a bad ports policy, or this is a particular port IP combo that should never be sent to, and put a community in that then tells the router to match a route map and block certain things based on that community, right? But the more common thing for the enterprise is that they'll put a single mitigation box from someone like Radware or A10 in there, because even if a flow platform does a really good job of detecting the signature of the attack, you really want to send it through a DPI box at that point to do a cookie challenge or whatever you may need to do at the next level that a flow platform isn't going to do.
Sure.
Right. So here's an example of a policy that we're looking at DNS servers, and I'm not going to try to go through each step of this, but you see the historical baseline section here where we're actually defining how to define the baseline, right? How far to look back, what percentiles to take, what to throw away. You don't want your attacks to become part of your baseline, for example. So there's certain things you can use from the signatures of the attacks to throw them away. Right? But the real key is then you begin to build a threshold. And in this particular case, it's a fairly elaborate one. But we're saying here that for this particular thing, it needs to be over 30,000 packets per second, over 100 flows per second. Flows per second is a really good indication of an attack because the ports are always changing, the source IPs are always changing on attacks, which each one of those changes turns into a flow. So coincidentally, it works out that that's a good indicator. And it needs to be more than 25 megabits per second. And it needs to be 150% of normal. And if all of those things happen more than 5 times in 1 hour, then I actually want to call a mitigation. Right? So in this particular case, it's detected an unusual event, and it's actually going to call a Radware box in this location and tell that Radware box to suck that traffic in, do DPI on it, and actually perform scrubbing on it. Right? And in reality, how does it work? Here we have a dashboard. Now this particular account, we've got things set very sensitive to throw off alarms. And what you can't see is what looks like green up there is actually orange on the screen. But we've got a whole bunch of alarms set for various things, from IPs that have high packets per second that they shouldn't have, to interfaces that are nearing capacity. So we could take this interface, for example, and open that up in the actual Flow Explorer and see what that traffic is. Maybe it's normal for this interface. Maybe it isn't normal. So let's tell this thing to look back over the last week. All right, so this is pretty normal that this interface is nearing its capacity at 20 gig, right? And in this particular case, the alert itself was set up that fired this was actually, the user didn't have to configure this alert and say, this is a 20 gig interface. This is where we combined SNMP information. We went and looked at the capacity information that the router said for that interface, and then we used it in the alerting system. Right. And then you could drill, like Avi was doing, we could drill into this and say, well, I'm kind of curious, what is this traffic? Where is it coming from, for example? Because maybe if those bumps weren't consistent, the user might want to know. And in this particular case, it's all coming from internal traffic inside the ISP, and a little bit of it's Akamai. So back to the alerting.
And 3 more minutes, and then I'll show a little NPM, and then we have to release this fine audience to torture the next vendor.
Torture.
So what's an interesting thing here real quick is to take a look at an actual attack that's occurring. So we've got 3 that were in mitigation and they cleared. So let's grab one of those. So instead of a user having to drill in and create dashboards, we can just actually take them right to a dashboard that has a whole bunch of panels that will drill in on that time range, on that traffic. So if you think about a network operator, they get alerted that there's this anomaly, could be a DDoS. They click on one button, and now it takes them to a dashboard that they can very quickly identify whether this is normal and the system misclassified it or whether it's an actual attack. And in this particular case, let me zoom out here. This one was primarily from port 123. This is showing that it was a whole bunch of ports it was attacking. It was sourcing from port 123. If I scroll down, I'm going to find that it's probably from weird countries. So normally the traffic at this point was 98% from the US, but in this particular case, it was coming from a handful of countries that would not be normally receiving traffic. From a network operator's perspective, you can look at this and within a few seconds say this is an attack. Right? This is not normal traffic. Right? So the goal here is we detected it. We give you a dashboard. You can build your own dashboard. It gives the people very quick response to tell what's happening.
So are you guys looking at any way to kind of enable
The greater
Yes,
good.
yes. So every MSA says you give the right to aggregate, present. We say obfuscated because you can't actually anonymize this traffic. And a lot of customers take that clause out, and we don't fight because it's their data, and a lot of them don't. And we think about that in 2 or 3 ways. One is, how do we make useful to the community, not just our customers' maps that are not just pew-pew maps, but actually like what's going on in the infrastructure. Number 2 is in the product, both for attack and for performance. Because again, if you've ever spent time debugging to the internet, sometimes it's more interesting to know that no one has a good path to Comcast in Boston than that you don't. Right. And so a lot of the technology that we're working on right now is just how do we, as Dan talked about, we have a lot of features built into the system. There is no account that has access to multiple of the backend, but we're actually building on top of the streaming database to do those aggregates, drop some information, and that'll be in the product. And there'll also be some things we'll be giving out to the community, like the Akamai State of the Internet report, which was originally my Perl code and monkeys, and we'll have our own version of that.
So is there a way to kind of query that data as a user today, or is it just going to be kind of?
No, not today.
As a
not today.
dashboard?
We have people that create accounts on. We have backbones that will create accounts and hand them out, so people can go look at one backbone. Will go look at another, but we don't have that. And again, it's just because it's sort of existential risk to the company if we screw up with the data sharing. So we're just. But I would expect it. I expect it to be sometime this year. And in fact, we have a hackathon on Wednesday, next Wednesday, where we'll both be playing with that. And by we, I mean me with Perl code. And also looking at sort of CDN attribution, using DNS findings so we can show you Akamai even though they're not 1AS and stuff like that.
It kind of follows up to my second question around communities for kind of sharing queries as they're doing development of the hackathon.
Yeah.
So there is active development on that from a handful of different levels. Obviously, we want to building network. We'll call it social network is a huge goal of ours. You have the ability today to export a query. You don't have the ability to let people cross-company see it. It breaks the fundamental security models of the database. But there are things we're working on to allow people. They're definitely within a company. You can share queries and you can share views, right? And now the next step is how do we move that outside the company, and that is one of the reasons we haven't done this yet. Is it's a delicate situation, but definitely something that's on our roadmap.
Great.
Right.
Now, how are you for supporting multi-tenancy if you're an MSP and you want to use this to gather different realms with perhaps overlapping address space, that sort of thing?
So there's 2 components to that. From the different address spaces, we partition things by device. And it's only when you select multiple devices that we do things to try to make it simpler for you. Right, so that answers that. The multi-tenancy perspective is we've got a few steps. The first step is giving people inside a company multi-tenancy, where you can actually say this department is only allowed to see these traffic from these source and dest IPs, right? Then moving in the role-based access control, and then moving into actually a portal that you could present that is, simplified enough that an end user could use it. Right. The challenge we have with that last step is as we interview people and talk to people, every single user has a fundamentally different thing that they want that to work.
But if you're an MSP and you're not presenting the Kentik interface to your customers, you've got that right now.
We have that today, and we have many MSPs that are using our API to pull that data and present it to the customer in their own portal. In fact, we even go as far as returning the actual image of the graph to you, so you don't even have to worry about pulling the data back and graphing it yourself in your UI.
Okay, nice. Okay, thank you.
You're welcome.